What's up, folks? In today's episode, we're talking about a sugar that's probably in your chewing gum or bubble gum called sorbitol that's being used to build soft and stretchy electrodes for inside the human body. They think it can be used to help solve things like Parkinson's, epilepsy, and spinal injuries, and causes less swelling and less damage than the materials that they use today. What's up, everyone? Like we said, today we're talking about the future of electronic implants in the body. But before we talk about the far future and the technology that's associated with how we get those implants done, let's get a little bit of a primer on how humans and machines are integrated in general with an awesome technical resource from today's sponsor, Mouser Electronics. They're awesome and one of our favorite companies in the world, really, because of their ability to not only be super connected to different points in industry and to different suppliers, and that's what makes them awesome when you're trying to order electronic parts, is they're connected with all these folks, but also from a technical perspective, they have the know-how from all those different partners, and then they communicate those understandings to us in resources that are pretty easy to digest, like this one that we're linking in the show notes, talking about human-machine integration and talking about how humans and technology, they start pretty separate, but the interface through which they communicate, it started with like using a keyboard on your computer, and then we got keyboards and mouse, and then we got touch screens. And initially, a lot of the next generation around virtual reality and haptics and neural interfaces are going to be used for gaming. But soon they're going to scale into real world work as well. And I've even heard this term HMI be used in factories to talk about how people communicate with the robots that are doing a lot of the work on the factory line. So it's an interesting kind of walk through this technology principle in general, which is connecting humans to machines, and then kind of the progression that we've seen in the next generation of technology, starting with gaming and leisure, and then making its way into the workplace, which is pretty well tied into what we're talking about in the meat of today's episode as well.
Yeah, I mean, I'm thinking about human machine integration and what my life was like, 10 years ago when I got an iPhone. It started to become part of my, like hourly day-to-day life.
Mm-hmm.
Then, a couple of years ago, I got the Apple Watch, and now it's integrated with my health as well. And I was a big hater of the Google glasses, but now I'm seeing everyone with those Meta spectacles, and I'm thinking that that's probably going to be the next leap that I'm going to be taking, especially as it gets more tools integrated into it, and it can benefit me in terms of how I do my job. So it's been crazy to see like what this ride looks like, where we start to merge more and more with technology as the years go on.
Yeah, I would say, there are folks who have like bionic prosthetics and stuff like that who are cyborgs in the like literal sense. But I would say I'm personally probably at a place where cognitively I'm a cyborg. Like so much of my thinking and productivity relies on a computer or in a machine. So having more seamless integration with machines, as scary as it sounds, would probably be a massive impact or a massive improvement on everyone's productivity, and kind of loops us into the meat of today's episode, which is a lot of the ways that doctors are communicating or connecting the human body with machines, specifically for treating diseases and then sensing and understanding where there are new diseases, is using electronic implants. So putting electronics inside the human body. Most of these implants need conductive hydrogels, which are these soft and stretchy materials that help sense the biometric signals inside the body. But the challenge is most hydrogels actually use toxic chemicals that leach into the body over time. So you've got this counterproductive approach where you're trying to treat a disease, or you're trying to sense if there's a disease, but by using these hydrogel implants in the body, you could be causing additional harm to the body over time. So that kind of lays the land of what the problem is. The solution we're talking about today is from Texas A&M. They stumbled upon the fact that there's a sweetener in chewing gum called D-sorbitol, which can be used to replace the toxic chemicals in hydrogels. D-sorbitol is non-toxic and it's biocompatible, meaning it's safe to be inside your body and with all your cells, and it won't cause any damage. and it directly replaces the harmful additives that are used in other hydrogels. I think it's a pretty interesting approach, and love the idea that there may be sugars or chemicals sitting around in the things as common as chewing gum that end up in hydrogels and make a big impact in the way that we develop electronics for inside the body.
Yeah, I wonder how they even stumbled onto that. But I was looking up, what the usual additive is for these hydrogels and
Mm-hmm.
why there might be issues with it. I think they were comparing it to platinum. And they were talking about how, long-term usage can have side effects for users. But the reason that something like platinum is added to the hydrogel is to promote, like ionic conduction.
Mm-hmm.
Free-flowing ions in the gel allow charge to be transferred, which is great. And then I had to remind myself of what even ionic conduction is, because I don't know about you, but it's been a minute for me
Yeah.
since I've thought of that. Um, and in comes ChatGPT. It was like, well, I literally it started typing, and I was like, I need you to like dumb this down. So it was like you should think about normal conduction, which is what I'm used to, and I'm sure Daniel, what you think of when I say conduction or electric charge being discharged, and probably our audience. It's like think of normal conduction that goes through a metal wire as electrons that flow like cars in this uniform fashion on a freeway. And I'm like, great, ChatGPT, that's exactly what I'm doing because it's easy to visualize that. And then it was like, cool. Now think about electricity in the hydrogel as these little ions that are like dispersed through the water like boats in a canal, right? You have this free form, no rigid structure, and the water in the canal is just kind of the medium by which they're moving through. So that's what the hydrogel is, and the additive here, the sorbitol, is I don't know, making the waves smoother so
Hmm.
that the boats can get around easier.
I like that analogy.
I hope. Thank you. It was a combination of me and ChatGPT, but if I'm being honest, ChatGPT did a lot of the heavy lifting.
You're the one who delivered it, so you can take the credit.
I will. I will. Thank you.
No, I like it, and it perfectly explains kind of what the usage of this sorbitol is in these hydrogels. One thing that I think is super interesting is that, um, we've been using platinum, which is typically used in these implants for this reason, but when they started testing it with the sorbitol, they were actually
Hmm.
able to prove that these hydrogels with the sorbitol carried electricity even better than the ones with the platinum.
Hmm.
So it's like, why use this toxic additive when the non-toxic alternative offers not just similar performance, but actually better performance? Um,
Absolutely.
and one of the awesome things that they did is they implanted these in rats, and they were doing testing around doing neural stimulation in rats. And actually, an interesting aside is the lab that's working on this type of technology, these hydrogel implants for treating diseases and nerve problems. What they're looking
Hmm.
at is potentially creating neural stimulation interfaces for Parkinson's, epilepsy, spinal injuries, and chronic pain. So thinking about how the electricity transmits through your body, through your nerves, and then having these electrodes essentially on in the nerve tissue or in the brain to help stimulate um, improved performance for folks who have these diseases. So it's really interesting to think about the application here about why conductivity means so much, because a lot of these
Absolutely.
diseases are oriented around the way that electricity is transmitted through the body, through the nervous system. So they're working on how to treat those using electricity. Having highly conductive hydrogel electrodes matter a lot, actually. And so they tested this in rats, and they were doing neural stimulation using these hydrogel electrodes inside rats. And then they had someone from the veterinary science group at their school um, take cross sections of the rat's nerve tissue and then identified, which one's the platinum, which one's the hydrogel, and does the neural tissue seem more aggravated, more swelled? What's the like immune response? Is the body rejecting these
Hmm.
electrodes, or is the body accepting these electrodes? And I'm just going to pull up the article to get the direct quote so I don't misquote. But they got Dr. Jones Hall, who's an associate professor at the College of Veterinary Medicine at Texas A&M, and
Hmm.
They said, I'm a board certified veterinary pathologist. I analyzed the histological cross sections of nerves. I discovered significantly more inflammation in the perineuronal tissue with implants containing platinum than there was in the surrounding nerves with electrically conductive hydrogel implants. So basically saying, this research group wants to work on the future of stimulating the nerves to solve things like Parkinson's, to solve things like epilepsy, chronic pain, or traumatic spinal diseases and injuries. You
Right.
want to create a device with electrodes that aren't rejected by the body and don't cause more issues in the body or more inflammation in the body. You want to create electrodes that help treat those conditions without making it worse. And it's promising to see that their board certified veterinary pathologist who's doing an external review of these implants saying that when they replaced the platinum with this sugar that's in chewing gum, that they were able to achieve similar electrical performance, but also improved, let's say, biocompatibility with the body in rat tests. So it's promising for future applications within other animals and then potentially humans as well.
For sure. And one thing I wanted to note, I don't think you mentioned it yet, but the reason they didn't just go with quote unquote normal implant, where it could be a piece of metal or whatever, the hydrogel allows you to get, directly at the interface of wherever the problematic region is because it's soft and flexible. So like if you want to stimulate a certain muscle, it can actually be embedded at that muscle tissue layer. And it'll bend with it. It'll keep bending with it for years and years and years to come. In fact, in the article, they were saying something like, ideally, we would want these implants to last a lifetime so that they would never even have to be replaced. And when you think about something that could have the mechanical properties to be stressed and brought back to a normal state thousands, if not millions of times, then a solid object doesn't make sense, but a hydrogel does.
No, and that makes a lot of sense around the inflammation as well. It's like
Hmm.
it just feels intuitive to say like, oh, I've got soft tissue inside my body. I should place a soft, flexible electrode on it, not a solid chunk of platinum metal. And so I think that kind of intuitively helps explain the improved performance they saw. It's not just chemical performance, it's not just electrical performance, it's also the pure mechanical biocompatibility with tissue. I could see why these flexible, again, flexible non-toxic electrodes are the clear choice. And an interesting note that they put in the article as well is they think that they can last a lot longer in the body compared to the platinum electrodes as well.
It's pretty much better on every front. And in terms of accessibility to these things, they mentioned that they're actually looking for industry partners, and they got some further testing coming up with larger animals. I think you already mentioned they did some testing with rats. They want to do some testing with larger animals and then find an industry partner before they get geared up to do human trials. So it looks like they're very serious about pushing forward with this and getting it into people's hands.
Yeah, it's insane that all this comes from a sugar and chewing gum, but pretty awesome.
Never undermine your chewing gum ever again.
I know, it's crazy.
Even though I only choose xylitol, so
That's what I was gonna say.
maybe I got to get on
You're
that
a
sorbitol.
non-sorbitol person.
I'm sensitive, man. I can't. I'm
That's
not
a
built for this.
that's another story for another podcast episode. But before we wrap up, let me do a quick recap of what we covered today. Um,
Okay.
these Texas A&M scientists found a way to make medical implants using D-sorbitol, which is a sugar that's found in lots of chewing gums. They used it to build a soft, stretchy hydrogel electrode that's non-toxic. It flexes just like body tissue, and it carries electricity better than metal. That's the material that's being used for the implants today. In rat tests, it caused less swelling and less damage than the contemporary materials, and they think it could lead to better brain and nerve implants for Parkinson's, epilepsy, spinal injuries, chronic pain, and more. And we also talked about potential cool uses in wearable tech and soft robotics as well. I just think it's crazy that this chemical, the sugar that's in your chewing gum every single day, is unlocking the next generation of neural interface devices. It's pretty awesome.
The life-saving chewing gum.
I know.
Who would have thought?
Who would have thought?
Not me. All right. Good stuff.
Yeah. See ya.